7.4, inverse functions. All right, when it comes to our functions, we have inputs, or our x values, and we have outputs, also known as our y values. We also call these domain and range. And this is our f of x. So what happens with our inverses is that these switch positions. And we denote an inverse with this -1 kind of in the exponent position. What happens is that these outputs become the new domain and x values. The x values of the original functions become the new range or y values. So when I have my original function x and y's, if I want the inverses, all I have to do is change my x and y's. So if I gave you a t-table, and I said this is f of x, could you give me inverse? Well, the only thing you have to do is switch. The x's become the y's, and the y's become the x's of the inverse. The domain of the function becomes the range of the inverse, and the range of the function became the domain of the inverse. If you want an equation, let's say I have f of x is 2x minus 4, and it says find the inverse. Well, again, we switch our x and y. Well, first of all, we have to make that a y. Then we get to switch them and solve for the new y. So x plus 4 is 2. So x plus 4 divided by 2 is y. And the last thing you need to do is write in proper notation. So we don't write y because that's not what we started in. We change it to f inverse. So there's my function. Here's the inverse function. And all I did was solve x or switch x and y, solve for the new y, and put it in proper notation. If you have two functions, an f function and a g function, you might be asked to see if they are inverses of each other. If two functions are inverses of each other, then their composites, and remember composites is what we did in the last section, will equal x. So let's say I have f of x is negative 3x plus 6, and g of x is negative 1/3 x plus 2. The composites are f of g of x and g of f of x. If these are truly inverses of each other, when I do the composite, I'm going to get x left standing. So we're going to try it. We're going to put g into the f equation. So my f equation, and I'm going to replace x with g, negative 1/3 x plus 2. When I distribute, I get x minus 6. Minus 6 plus 6 is x. So that one worked. Now do it the other way, f into g. Well, g is negative 1/3 x plus 2. I replace x with f, negative 3x plus 6. When I distribute, I get x minus 2 plus 2, which is x. This proves inverses. When you do composites, you are proving inverses. If you're looking at a graph, and I say f of x is whatever, it has an inverse if the picture passes the horizontal line test. So here's a picture of a parabola. If I do a horizontal line test, it hits more than once, no inverse. Here's a picture. When I do a horizontal line test, no matter where I do it, I only hit one time. Yes, there is an inverse. So, of a function, picture of a graph of a function, you can tell what the inverse, if there is an inverse, if you can run a horizontal line test. And that's 7.4.